Well, we're now at the Grohr Radiosonde stand where we're about to look at their new radiosonde, perhaps unsurprisingly, and I'm joined by Florian from the firm. So talk us through, you got a radiosonde in front of you there. What's the difference between that, I guess, in terms of what you're offering now, perhaps what you're offering 24, 48 months ago? This technology is changing, isn't it?
Oh yeah, it is a little bit. In general, radiosondes are consumables. They fly up on a balloon up to 30, 35 kilometer altitude, and while they fly up, they measure the atmosphere, like temperature, humidity, wind speed, and wind direction. Humidity is the most critical parameter to measure because when it gets very cold, up to minus 80 degrees or something like that, it might freeze the humidity sensor. This is why we apply a heater on the humidity sensor now to avoid freezing. This is probably the latest development we have on this radiosonde here. Apart from that, not also for other companies, also for us, sustainability is the most important thing. Yeah? And this is why we reduce everything that is non-disposable on the radiosonde as much as possible. One very critical example is the cord between the radiosonde and the balloon.
So how is this different to how it used to be?
It used to be polyamide, plastic, and plastic material to unwind it. The corpus was plastic. In our case, it's made of wood, latex, and cotton. So everything fully disposable. So no fish can die from that.
It's good to hear.
Yeah.
And are these innovations coming, I guess, from sort of the Grohr Radiosonde's brains? Are they coming from customers who are saying we want to do it a different way? What's the kind of motivation for these innovations?
It's a combination of all that. Of course, we see what the market asked for. We watch TV and know sustainability is a big thing. And we have our own impressions of morality and whatever. And we have a smart team of people who can really then do what we need.
And what about the guts of the radiosonde, the insides, which of course is so important to have that high quality technology bringing back the data which can really tell the story of the climate. What's on the inside then? What's the technology inside?
The technology inside is actually nothing else but a PCB. It's a small PCB with batteries and a sensor boom. And the technology is improving year by year. For example, we have a GPS module on there, which is not really only a GPS module, it's a GNSS module. That means we do not only rely on GPS, but also on Beidou, GLONASS, and maybe Galileo in the future. That means we increase the reliability of the position measurement and also the accuracy.
And are the decisions made on the environmental side about what you put on that in terms of the metals you use and so on? Are you looking at that option as well, how to make that more environmentally friendly?
Absolutely. We are always watching the technical possibilities, and this is why it changes year by year, maybe in small steps, but it does change. One example is the housing. It's still styrofoam, but we're looking for alternative solutions. But even today, because we have so little mass of styrofoam, and that is the most important for us, we think, or we are very sure, we are the most sustainable company in that business. This is what our calculation shows. Other companies who say they have a new sustainable housing instead of styrofoam, after all, they still have so much plastic around it that the content that is non-disposable is higher than in our case. This is why this is a key for us. It's very important.
But the great thing about having different companies do it is that race to innovation. You're all facing the green direction. Yeah.
It is definitely. Yeah.
I suppose. Look, we've looked at the hardware. We know it's producing high quality data. Let's sort of wander around this way because it's what happens to the data afterwards, isn't it? Which is so important. So this is your software solution. Tell me about this.
Exactly. We have different options for the software. Our normal GROMAT software is a software suite that covers all needs of meteorologists, you can say. So it processes the data that comes from the radiosondes, visualizes it, and transfers it to so-called messages that can be sent to WMO and other institutions. This here, GROMAT X, is something new that we show this year. With this software, you can receive multiple radiosondes at the same time. So some customers do not only want to fly one radiosonde at a time, but maybe 8 at the same time. In different balloons, so they cover a wider area and get more information from the atmosphere. And this is easily displayed with that software, GROMAT X. So all 8 radiosondes are shown in one display. So it's easy to compare. Then we have a smartphone app, GrowGo, that makes it easy for the managers of upper air stations to manage all their stations. Maybe they have 20 stations with a smartphone, so they can sit at home with their family and check in the evening. Now we should have flights on all stations because they all fly at the same time. Green, 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 green. One is red. Yeah? There's something going wrong at that station. Then he can give a call. What's wrong? No gas. Operator is ill. Something like that. Yeah. So it's a monitoring tool actually. Yeah? Which is quite good. And then last option, we have a sounding center, which is a cloud-based solution that weather services, operators, whoever can manage all their stations with the same capabilities that we have here, but all the stations as a cloud-based solution.
Okay. Florian, really, really interesting. Thank you for talking to us about it.